Let's turn our attention to the constant c, sometimes known as the constant of integration. So far, have you noticed that we have said that f is an antiderivative of f, not the antiderivative, meaning that there could be more than one option. Let's consider the function f of x is equal to 2x plus 5. Its derivative would be f prime of x is equal to 2 plus 0. The derivative of any constant in a function is always 0. Therefore, when finding the antiderivative, we need to consider that the original function could have had a constant value. If we go back up here to our original, let's consider the case if we had f of x was equal to 2x plus 1. What would the derivative of 2x plus 1 be? It would still be 2. So we don't know the value of the constant term, therefore we use a general c to explain that. Continuing on with our conversation about the constant c, let's determine the antiderivative for each of these functions below. So given 0, if this is the derivative, what was the original function? Or if we consider 2x to the fourth, if that's the derivative, what was the original function? And it would be the same thing for sine of x, or 5, e to the x, or even 2x plus 5. If these are all derivatives, what was the original function? Well, here are some options. Okay, y could have been any one of these constants because all of these constants have a derivative of 0. Going down here to 5, it's possible that y could have been 5x plus 9 or 5x minus 10 because all of these functions have a derivative of 5. If we look over here, we have 2x to the fourth. The original function could have been 2/5 x to the fifth plus 1. It may have even just been 2/5 to x to the fifth power. Both of these have a derivative of 2x to the fourth. There are an infinite possibilities for each of these functions because any constant value added to the function would still produce the same derivative. Let's revisit our example from before, where f of x was equal to 2x. We found that one possible antiderivative of f was capital F of x is equal to x squared. We can express the family of all the antiderivatives of f of x equal to 2x by using c at the end to represent the potential constant that could have existed in the original function. It would look something like this. Capital F of x is equal to x squared plus c. This is what we call the general antiderivative. And this c would be the constant of integration that would be added to any time we integrate a function because there is a possibility that a constant was at the end of that function.